The entire universe started in an infinitely small point before it made a Big Bang. There were 4 fundamental forces that were in play: gravity, strong force, weak force, and electromagnetism. At this point, it was still too hot for the quarks to stick together. Light waves would spontaneously turn into matter and antimatter, and gravity would force them to collide, and then they would explode, turning back into light. After a certain amount of time, the universe would cool enough to allow strong force to come into play and let quarks stick together, making protons and neutrons. Due to the electromagnetic force, the protons would push each other away and attract the neutrons. The neutrons and protons could combine into different lightweight atoms, such as hydrogen, helium, lithium, and beryllium. But it was still too hot for electrons to join in. When 2 protons were met with the weak force, it could turn one proton into a neutron and would release a positron and a neutrino. At this point, it was cool enough that the electron could join and make a heavy hydrogen atom, starting the era of the atom. When enough of these elements were made, they would form into a giant gas cloud in space, and gravity would turn it into a protostar, releasing massive amounts of energy on either side, leaving nothing but a condensed sphere of hydrogen.
After the protostar is born, it begins to undergo nuclear fusion, fusing basic elements like hydrogen into heavier elements like helium. This process continues up until iron, where a tipping point occurs in fusion. The amount of energy gained from the fusion is less than the amount of energy put into the reaction. The balance of gravity and fusion is broken, and the star starts to collapse in on itself. The product of this collapse depends on the mass of the star, but for this one it was heavy enough to become a black hole. A black hole's gravity is so strong that light cannot escape its pull. Once something passes its event horizon, it can never come back. A black hole stretches matter into a long string of superheated plasma. The scientific word for this phenomenon is spaghettification. At the center of every galaxy lies a supermassive black hole. For the Milky Way, this is Sagittarius A. 10 billion years after the Big Bang, Earth becomes a suitable planet to harbor life. It starts with small single-celled organisms that feed off nutrients dispensed by hydrothermal vents. They gradually evolve into bigger and more complex animals over time until the first land-walking animal, the lungfish, came around. From here, the dinosaurs evolved about 235 million years ago from present day. The continuity of dinosaurs lasted around 165 million years before the Chicxulub asteroid wiped them out, leaving humans to become the dominant life form on Earth.
In 5.5 billion years, our sun will run out of hydrogen and will consume Mercury, Venus, Earth, and Mars. After another billion years, the sun will run out of elements for nuclear fusion and will explode, creating a white dwarf in its remains. As discovered in 1929 by Edward Hubble, it was revealed that the universe was expanding at an increasing rate. Through observation of nearby galaxies and stars, we were able to tell that they were moving further away from us due to the redshift of light that was seen. In one possible instance of how the universe ends, it was theorized that dark matter could have the gravity to stop the universe's expansion and have it collapse in on itself, and possibly make an even bigger bang. But hey, that's just a theory. A Big Bang theory. Thanks for watching.